This is the kind of problem that challenges your analytical thinking and sharpens your mind. Hey everyone, welcome to Geomathic. In the figure, there are three circles whose centers lie on a straight line. The middle circle is positioned between the other two, and its circumference passes through the centers of the two outer circles here and here. The two outer circles are externally tangent here to each other. All three circles have the same radius equal 8. And we are asked to find the area of the shaded region, means sum of the two green parts. Well, as you can see, finding the area of the shaded region is not easy by itself. So we need to use some other geometry shapes. To start, I connect the center of the three circle with a straight line. Like this. So far nothing special comes out, but when I connect this point to this one, and of course this point to this, a triangle is formed. If you look carefully, each side of this triangle is a radius of a circle. This side is the radius of the middle circle, this side the radius of this, and this side of course the radius of the outer circle. And since all the radii are equal, the triangle is equilateral, and these angles here, here, and here all are 60 degrees. By connecting the remaining points, as I do, we form four equilateral triangles which are equal. And as you can see, 8 equal circular segments. 1, 2, 3, 4, 5, 6, 7, 8. Why are these 8 circular segments equal? Because each one lies opposite and equal 60 degrees. Here, 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 and here, and these 4. So now we have 8 equal circular segments and 4 equal equilateral triangles. Now if we calculate the total area of the circle and then subtract the area of the 4 equilateral triangle and 8 circular segments, we obtain the area of the shaded region here and here. Next step, the area of triangle is equal to 1/2 the base multiplied by the height. And to find the height, we have to use the Pythagorean theorem. We know in an equilateral triangle like this, the height is also median. Dividing the side opposite means this into 2 equal parts. So I draw it. We know each side equals 8. So the half of these sides equals 4. Then the Pythagorean theorem says 8 square here equals h squared plus 4 squared. Then h squared equals 64 minus 16, and h equals the square root of 48 equals 4 times the square root of 3. So we found height. Now the area of each triangle equals 1/2 times height, 4 times a square root of 3 times base, which is equal to 8, equals 16 times a square root of 3. And of course we have 4 triangles, so total area equals 4 times 16 times a square root of approximately equals 110.85. So remember this. Now it's turn of this a small circular segment. To find the area of the circular segments, we subtract the area of the triangle from the area of 1/6 sector of the circle. Why? Because we know the whole area is 360 degrees, and because this angle is 60, so this part is 1/6 of a whole circle. Then the area of this part is also 1/6 of the whole area of a circle. So I write area of circular segment 1/6 times pi times r squared approximately equals 64/6 times pi, which approximately equals 33.5. And this is the area of the 1/6 circular sector, and we should subtract the area of a triangle from this value to obtain the area of each circular segment. So I show this area by red color. Now red area equals the area of 1/6 circular sector, which is 33.5, minus the area of an equilateral triangle, which is 16 times a square root of 3. Approximately equals 5.78. So this value is the area of this red section, and of course we have 8 of them, so 8 times 5.78 equals 46.24. So we have this value for 8 circular segments here, 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 this one, this, and this one. And of course, this value, which is the area of these 4 equilateral triangle. And now for the final step, to find the shaded area, we should subtract this 2 value from the whole area of the circle. So the whole area of a circle equals pi times r squared equals 64 times 3.14 equals 200.96, and this is the whole area of a circle. Now shaded area. Equals the whole area of a circle, 200.96, minus the area of all 8 circular segments, 46.24, minus the area of these 4 equilateral triangle, 110.85, which is equal 43.87. So the shaded area, which is sum of these 2 green part, equals 43.87. Have a good time.